All right, we just talked about multiplying imaginary and complex numbers. Now let's talk about dividing them and conjugates. Remember that sometimes we can use conjugates, opposites, to get rid of certain things like radicals, or now we can even get rid of imaginaries. If you remember when we tried to rationalize denominators, right? We had to get rid of the radical on the bottom by multiplying the top and the bottom by the conjugate. Well, we can do the same thing here with complex numbers and imaginary numbers. We can divide by getting rid of the imaginary number in the denominator. Because remember, an imaginary number is really just a negative square root. So if we want to get rid of the square root, we also want to get rid of the i's, or the imaginary pieces. So in the first one, I have 26 divided by 5 plus I. You notice that there's two terms on the bottom. So in order to get rid of the imaginary piece on the bottom, I have to multiply the top and the bottom by the conjugate. So I'm going to multiply the top and the bottom here, the numerator and denominator, by 5 minus I, the conjugate of the bottom. When I do that, I'm going to go through and distribute the numerator by 26, and I'm going to go ahead and FOIL the bottom. 26 times 5 is 130. 26 times negative 1i is negative 26i. Now let's FOIL the denominator. 5 times 5 is 25. 5 times negative I is negative 5i. I times 5 is 5i, and I times negative I is negative I squared. Oh, but did you hear it? I got a negative I squared, don't I? And remember that I squared is the same thing as negative 1. So if I have a negative in front times another negative, that really makes me a positive one, right? So really, and look at this, the two middle terms should always cancel out, right? A negative 5i and a positive 5i. So really in my denominator, I have a 25 plus 1, which is really 26, yeah? On my numerator, it looks like I have 130 minus 26i, and my denominator, I have a 26. Now be careful not to reduce just those 26's. You notice that there's actually 3 different terms in my problem. And if we're reducing, we have to reduce by a common factor. Everybody has to have it. So is there a common factor between 130 and 26 that I can maybe GCF out in my numerator? Well, actually, 26 can be taken out of both of those. So I can actually factor out a 26, leaving me with a 5 minus 1i. My denominator is still 26. So what do you notice? Well, you notice now that there's a factor of 26 on the top and a factor of 26 on the bottom. We're not connected with plus or minus signs, but they're just being multiplied. So I can reduce by 26. I can reduce my numerator by 26 and my denominator by 26, leaving me with a final simplified answer of 5 minus 1i. No denominator, right? So no i's in the bottom. And that was my goal. So let's do the same thing, same idea with b. Let's see if we can get the I off our denominator. So on this one, it looks a little bit different than a because there's just one term in the denominator. So I don't necessarily have to multiply it this time by the conjugate. All I have to do is make sure that I multiply it by something that's going to get rid of the I in the denominator. How about just another I? Then I can take this I and distribute it to both things in the numerator, and then I can combine my 3i and my I in my denominator. Let me show you what happens. I have I times 6i, which is 6i squared, and I times 3, which is 3i in my numerator. In my denominator, I have 3i times I, which is 3i squared. Now, it looks right now like I didn't get rid of any of the i's, I just added more, right? But if you notice, I squared is really negative 1, and that means that this I squared is really negative 1. So in my numerator, I really have a negative 6 plus 3i, and in my denominator, I really have 3 times negative 1, or negative 3, right? No more i's in my denominator, which is what I wanted. Now be careful, please don't reduce those 3's off, because there's 3 terms, 3 pieces. You can only reduce if you can reduce all 3 pieces by the same amount. So let's see if we can factor the numerator. If we can factor and find a common factor, then we can reduce all pieces. Looking at my numerator, I can actually factor out a negative 3, can't I? When I factor out a negative 3, that would leave me with the 2 minus 1i. My denominator is negative 3, and then you notice that I have a common factor in my numerator and denominator. I can reduce each one by negative 3, and that leaves me with a final reduced answer with no denominator, that means no i's in my denominator, of 2 minus